To create and place any instance, either active or passive, you can go to the Create menu and choose Instance. This opens the Add Instance form that you see here on the screen. You can also press the I bind key to perform the same function. Choose the library, cell and view of your instance. The library field is populated by the definitions in your cds.lib file. Some basic libraries are referenced from your software install, and you will mostly use libraries defined in the PDK of the Foundry node you are targeting for the design. In this example on the screen, you can see that a resistor is chosen to be placed from the analog lib, which contains analog design primitives. At this point, I should mention that whatever you place on the schematic, you are actually placing a symbol view of the instance. You can even create a symbol of a very large schematic for future reuse. Once you choose that you want a resistor to be placed, the form modifies itself to show you the CDF properties of the instance. Here you can choose to specify the values of the resistance, and if you were using a model file from a PDK, you could specify the model name of the resistor in the provided field. You can also choose to add wire stubs if you want when placing the instance. So in this example, it would have two wire stubs coming out from the terminals of the instance. With the rows and columns set to a value of 1 in the array field, a single instance will be placed. You can modify it if you want to place multiple instances. Now bring your cursor into the canvas and click once to place the instance. You can also choose to place it the way it is or click any of the orientation buttons to place it in different directions. So be careful when you are placing these transistors. You can keep placing single instances until you click the escape key on your keyboard to end the placement mode. You can choose to ignore certain instances during the netlisting of your design. There is a property called NL action that you can set to ignore, and it is visible in the property editor assistant. To do this, you can choose Edit Ignore Instances from the menu. For pre-selected instances, you can select the instance and then choose Edit Ignore Instances. And for post-selected instances, you can select Edit Ignore Instances and then you can click on the instance. This is a toggle-based command and you can use it to turn this property on or off. You can use the Ignore Properties tab in the Editor Options form to view the registered and enabled Ignore properties. You can select or deselect the checkboxes to enable or disable the Ignore properties for an instance. Along with instances or components that you can place from the analog primitive library analog-lib that comes in with your tool install, every design needs to have source and ground definitions. You can choose from independent, dependent and piecewise linear sources. An instance of the cell ground or GND is required in the design for DC convergence. Sometimes you may even need to use voltage taps to transfer voltages and currents throughout the design without using wires, so that you can use tap symbols such as VCC, VCCA, etc. that are available in the analog-lib library. Use toolbar buttons or options available from the Create menu to provide interconnects between your instances and pins. This is called wiring your circuit. You can choose to create narrow or wide wires. The Create menu also highlights bind keys that you can use. You can see the bind keys over here in the snapshot. And while connecting two components, you can press F3 on the keyboard to bring up the Add Wire form that allows you to change the draw mode. You can change the width, the color of the wire and even the line style such as solid, dashed, dots, etc. You can also use the middle mouse button to change the draw mode. You can follow different shapes as illustrated while drawing. You can add names to the wires that you create. If you do not add names, default names will be added by the software and you can see them in the netlist once it's created. If you add names, it makes it easy for you to distinguish between the connections. This is applicable for the narrow as well as wide wires that you create in the schematic. For creating wire names, choose Create Wire Name and it brings up the form that you see here on the screen. You can enter a name in the names field that is provided over here, and you can change the font and entry style. Also, you can change the way you would like the name to be displayed. You need to draw wires between different instances and from pins to instances to create connectivity and establish design logic. You can create narrow or wide wires in the schematic. You can use wide wires to indicate multiple signals on a wire. The system does not force or check this. You can draw wires at any angle, but most designers frequently restrain wires to orthogonal lines. You can choose from different draw modes. Full routing is the default mode, and the route draw mode chooses any 2 points in your design, and then it automatically routes a wire around components. If a routed net remains dotted, it is because there is no clear routing channel. This can happen if the instances are too close or they overlap the selection boxes. To solve this, move the components further apart to give a routing channel. More information on route methods is included in the schematic editor reference documentation. Also, always try to label your wires. Labeling wires gives the corresponding net a meaningful name in the simulation results data. Otherwise, nets are system generated. Otherwise, nets are system named. There is some control over the automatically generated names, but these might not be as meaningful as custom names. On this slide, let us take a more detailed look at interconnecting components. You can connect components physically as shown in the first diagram here of an inverter. You can see an example of wire-to-wire connections. You can also see a pin-to-wire connection forming a node. In this diagram here at the bottom left, there are two inverters connected back to back in a pin-to-pin connection. Although this is possible, it is suggested to avoid this and use a wire in between them to create a net connectivity. You can also connect components by name. If two wires are labeled with the same name, they become part of the same net when connectivity is established. You can see this in the diagram over here on the right. If a net is unnamed, the system generates a name. Also, if a wire is connected to a schematic pin, then the pin name is used to name the net by adoption when connectivity is established. You can also see that over here in the diagram on the right. Now, any net or pin name that ends in an exclamation point will be a part of a global net when connectivity is established. Global nets are automatically connected through the hierarchy without the use of any wires. For example, voltage taps have symbol pin names that end in an exclamation point. If a wire is connected to a point that has a global name, the pin name is used to name the net by adoption. You can see that example here in the diagram on the right. This is how voltage and ground signals are propagated throughout a design.